Today's speakers today are Rachel Curry, the Illinois Extension Ag and Agribusiness, an Illinois Extension Ag and Agribusiness educator, and Nicole Haverback, the Illinois Extension Watershed Outreach Associate, or yeah, and one of those. We have two, right, in Illinois. And so we are excited for you all to share you two to share your expertise with us today. So welcome, and I will turn it over to you.
Need to make sure I remember to unmute. Well, welcome everybody, and thank you for joining us today. Today we're just going to give you a brief background on hypoxia, as well as the Illinois Nutrient Loss Reduction Strategy, or the NLRS, before we dive into some of the more recently added ag conservation practices that help improve water quality and reduce nutrient loss. Terraces, saturated buffers, and WASCOBs are just some of the possible practices that can be used to reduce nutrient loss and improve water quality that are part of the Illinois NLRS. So to start things off, we thought it was important to make sure that everyone understood exactly what hypoxia is, what causes it, and what are the implications. The leading cause of the hypoxic zone is excess nitrogen and phosphorus. But we also want to make sure that we're maximizing our plant growth as well as the nutrient use efficiency. And so for those reasons, we want to mitigate nutrient loss. The hypoxic zone is actually caused by algal blooms, and they feed on this excess nitrogen and phosphorus in the water. And once those nutrients are used up or the season changes, the algae are going to die off and decompose. And when they decompose, it uses an enormous amount of oxygen that's in the water. And so when they are decomposing, that process removes oxygen from the water. The map on this slide is of the hypoxic zone in 2023. And there's the dark red outlined with black right here. And those are areas that contain less than 2 milligrams per liter of oxygen. And with that little oxygen in the water, marine species are unable to survive. So if they're not able to leave the area, they're going to suffocate. Now, NOAA goes and measures the hypoxic zone annually. And so this most recent report was published on August 2nd, 2023, and it measured the hypoxic zone to be approximately 3,100 square miles, which is almost 2 million acres. And to put that in a little bit of perspective, that's about the same size as Yellowstone National Park. So this graph actually shows the size of the hypoxic zone each year. And as you can see, it varies in size, just like it varies in shape. And they've been measuring this since 1985. We have the goal level, which is the dotted line across the bottom, and that's at 1,900 square miles. We have the running 5-year average, which is the dotted line above, and the last bar shows where we are currently. And so our 5-year average is sitting at about 2 times the goal set out by the Hypoxia Task Force. Now, beyond this being just an environmental issue, the hypoxic zone has some serious economic implications for the fishing and tourism industries in the Gulf state. But it's important to keep in mind that algal blooms also impact our local watersheds and can result in the closing of the recreational areas here in Illinois, as well as decreasing our drinking water safety. So that brings us to the Illinois Nutrient Loss Reduction Strategy. And so the U.S. EPA tasked the 12 highest contributing states that drain into the Mississippi River to create plans on how each one of their states is going to reduce nutrient loss. The Illinois plan was released in July of 2015 and addresses nutrient loads from 3 different sources. We have our point sources, our urban stormwater, and non-point sources, which are typically agriculture. And in our original report, we set out goals, and we have our interim goal to reduce nitrate nitrogen by 15% and total phosphorus by 25% by 2025. There's a final goal to reduce the amount of nitrogen and phosphorus by 45%. Now, since the plan was released in 2015, we've had 3 biennial reports that have been published, and we have a 4th one coming out a little bit later this year. Now, the biennial report is just one way for us to track our progress towards reaching these outlined goals, but it's also a way to highlight the work of all of the partner organizations that are supportive of the NLRS. Our partnerships are one way that our plan is unique compared to other states, and the efforts of all of those involved are how we're able to make our progress. And the partner organizations include organizations that fall under agriculture, point sources, public works, government, and environmental and conservation groups. So we've got a wide variety of groups coming together and working towards a common goal, which is a really exciting thing. And we've been talking about the Gulf of Mexico and, saying that, yes, there are issues here in Illinois, but the Mississippi River Basin is a large area. It's about 50% of the US. So you have to wonder, why is Illinois part of all of this? Well, there was a study that was done in 2008 that modeled nutrient loss. And in this study, it identified Illinois as the largest contributor of both nitrogen and phosphorus to the Mississippi River and eventually the Gulf of Mexico. Now, keep in mind, as we're talking through these different conservation practices, that nitrogen moves really easily with water. And so we see a lot of the nitrogen loss through our tile drain systems. And we have the majority of our tile drainage in the central and northern part of the state. So that's where we're seeing the majority of our nitrogen loss. Phosphorus is a little bit different. It actually adheres really tightly to soil. So as the soil moves, the phosphorus is also moving. So think about erosion. So erosion tends to be more predominant in the southern part of the state where we have a lot more of the rolling topography. I mentioned the different sources that the NLRS addresses. We also refer to them as sectors. So the 3 different sources or sectors that the NLRS examines for nutrient loss is urban runoff, which is what goes down the storm drain. So think about stormwater when you hear urban runoff. Point sources, which are typically wastewater treatment facilities, and then agriculture. On these charts, it shows the percentage that's attributed to each one of those sources. So ag is the highest contributor of nitrogen loss at about 80%, and ag and point sources are split evenly for phosphorus loss at 48% each. The majority of the work that Nicole and I do is focused on education outreach that's geared more toward the agricultural conservation, because ag is such a high contributor, and right now all of the ag conservation practice implementation is voluntary, which is unlike the point source sector, which is highly regulated. And since the NLRS was put together and published, they've created different scenarios or different ways that we might be able to reach our goals for nutrient loss. And this is just one of the scenarios that's been put together as a way that we can reach our 45% reduction in both nitrogen and phosphorus. And I pulled this particular one from the 2021 biennial report. The navy bar that you see on the graph is the implementation level needed to reach our 45% reduction for each one of those practices. The orange bar is the implementation level as of 2019. And then there's also blue and lavender tick marks, and those represent the interim nitrogen and phosphorus reduction implementation levels. So we are making progress towards reaching our goal implementation, but there's still room for improvement as we're working towards both our interim and our 45% reduction goals. And I'm sure you can notice that there are quite a few practices that are part of this scenario, but we're always looking to add new practices that enable us to create more robust scenarios. And since we're talking about the most recently added practices today, I wanted to give a brief overview of the process of how we add a new practice to the NLRS. The practice submission is typically done by one of our partner organizations, one of the groups I mentioned earlier, and they submit the proposal, and it has to come with research to support the addition, and that must be science-based research. The proposal goes through several review processes before it's recommended to be included in the next biennial report. And we've recently made a slight change to the practice proposal submission process. Originally, it was on a biennial, a biennial timeline, but this year we started doing an annual review process. So if a practice is sent back to the organization saying it needs some more research or more local research, it can be submitted the following year instead of having to wait 2 years before it's reconsidered. So all of these practices are rated for their nitrogen and phosphorus reduction efficiencies. The strategy is always evolving and adding new practices to the list of approved conservation practices. So over the last 2 biennial reports, the 2021 and the one that's coming out later this year, we've had 3 practices that have been added, and those are the ones that we're covering today. And if you're curious about all of the practices, Nicole and I just published a fact sheet on the NLRS and the ag conservation practices, and it highlights nutrient loss in Illinois and the NLRS, as well as provides an overview of all of the NLRS approved ag conservation practices, including their nitrogen and phosphorus reduction efficiencies. And I believe that we have the link to access the fact sheet that we'll be putting in the chat, but you can always reach out to us and we're happy to share it with you. Now, eventually, this and our other fact sheets will be housed on the Extension Nutrient Loss website, which is currently in production. And with that, I'm going to move on to the conservation practices, and we're going to start off with terraces, which were added in the 2021 biennial report. So what exactly is a terrace? Well, it's an earth embankment or a combination of ridge and channel constructed across the field slope to reduce erosion and trap sediment that manage runoff from a field. And these are pictures of terraces from central Illinois. So the embankment actually captures the runoff and the soil erosion that's caused by water and the slope length. The terrace has to be along the contour and follow the contour of the land. And it also has to have outlets that convey the water runoff. So overall, it provides erosion control while maintaining farmability. And there are 4 different configurations of terraces. You have the broad-based, which is farmed on both sides and is typically used on more uniform or gently sloping fields. You have the steep back slope, which has a steep downstream slope in permanent cover. The narrow-based configuration, which is steep on both sides and it has to have permanent cover planted on both sides. And then there's the flat channel or the level, and that's used to conserve moisture as well as provide erosion control. Terraces are Conservation Practice Standard, or CPS 600, and it was updated in December of 2022. Now, again, it's an earth embankment or a ridge and channel that's constructed across the field slope. I'm just going to reiterate that because it makes a difference. The purpose of a terrace is to reduce erosion and trap sediment while managing runoff. And the size of the earth embankment or the ridge has to be big enough to catch enough of the runoff from a 10-year frequency 24-hour storm. Now, there is some maintenance that's involved with this. You have to do periodic inspection and repair of the terraces and the outlets to make sure that you're keeping up with the standards. You need to maintain the terrace ridge height as well as the permanent vegetation on the ridge. And then you need to remove the accumulated sediment periodically. And the life expectancy of this practice is 10 years. The terraces should be used where the soils and the topography are such that terraces can be constructed. You're obviously not going to put a terrace where it can't be constructed, right? You need to make sure that you have a suitable outlet to be able to move the excess water from these storm events. And it should be used when one of the following conditions, when you have one of these following conditions. Either the soil erosion due to water and excessive slope length is a concern, where excessive runoff is a concern, and or where water conservation is needed. And as with everything, there's going to be pros and cons. So on the positive side, any topsoil that erodes can be captured and spread back on your field. You can use diverse and native mix for your vegetation, which is great habitat for pollinators as well as other wildlife. You reduce surface runoff and erosion, and it can actually be used in conjunction with edge of field practices to capture nitrogen. Things that you want to consider if you're interested in terraces is that it could potentially limit the size of equipment that you use on your farm, as well as the type, depending on the spacing of these terraces. There is still a potential to lose topsoil, and there is some maintenance involved. Now, like I mentioned at the beginning, terraces were added back in the 2021 biennial report because it was an established practice that had been utilized in Illinois for a number of years. Current literature has little on the terrace phosphorus dynamics, but the science team, when they were reviewing, determined that any new research would just refine the nutrient loss reduction efficiencies. And so they used 40% for the phosphorus reduction, and no nitrogen reduction was considered because we're talking about soil moving and not looking at the water. And these estimates are based on the lowest reported phosphorus loss in the proposal submission. And so it's likely that that number is a little on the underestimated side, but we also have the estimated annual operation and maintenance cost was determined to be $40 per treated acre per year. And that's based on the annualized installation costs, the reported installation costs, and the operation and maintenance costs. Now, I mentioned as a possible pro that you can add edge of field practices to help with the nitrogen coming from the field. So this is a wood chip bioreactor, and the outlet for the terrace right behind it is actually into this wood chip bioreactor. So it's treating the nitrogen leaving the field in this reactor before it's sent on down the tile drain. And with that, I would like to pass it over to Nicole, who's going to talk about saturated buffers.
Thank you, Rachel. Saturated buffers were added to the nutrient loss reduction strategy best practices in the 2021 biennial report. So what is a saturated buffer? Saturated buffers store water within the soil profile of field buffers by diverting tile water into shallow laterals that raise the water table within the buffer and slow outflow. So in a conventional outlet, the water goes from the field underneath the vegetated buffer through that tile drain, draining directly to a stream or ditch. So how exactly do these practices differ from the conventional outlet? A saturated buffer is a vegetated buffer with a lateral tile line installed parallel to a ditch that tile drain flow is diverted through a water control structure. So as water drains into the buffer, the living roots of perennial vegetation absorb the water and nutrients, specifically that nitrate nitrogen, which travels with the water. So ultimately, tile drained water is directed into these water control structures, which are shown in that bottom picture. And the water control structure intercepts the water and redirects it underneath of that vegetated buffer through a perforated tile pipe to increase soil saturation. However, there's also a bypass for those high flow events, which is shown in that bottom photo there. to prevent any backup in the field. And then also while crossing the buffer through natural processes, denitrification occurs, which is a microbial facilitated process of nitrate being converted to nitrogen gas, along with those nitrates and water being uptaken by those plants that are within that vegetated buffer. Saturated buffers are Illinois Conservation Practice Standard 604 and use water control structures similar to those utilized in drainage water management. Saturated buffers are also site-specific and require certain conditions, including a minimum of 1.2% of the organic matter in the top 2.5 feet of soil, and a minimum vegetated buffer zone of 30 feet with that stream or ditch. And then other considerations include the absence of abandoned drain pipes or any clay tile that is in that buffer area that could continue to drain that buffer. So as mentioned in the previous slide, saturated buffers require certain conditions for construction, which can be limiting. So saturated buffers typically treat systems operating on a single field on 6 to 12-inch mains, and there needs to be at least 30 feet of perennial vegetation available. So if there's not a buffer that's 30 feet, you need to be either willing to put one in or have one available. And then there needs to be stable stream banks. And then again, that buffer must contain 1.2% soil organic matter in the top 2.5 feet of of soil. And then needs to be no sand lenses or gravel layers in along the length of the distribution line. And conditions like a restrictive layer need to be present in order to create that saturated zone. And ultimately, they work the best where that outlet is lower than the contributing field. So saturated buffers offer a list of pros and cons to consider regarding the installation of the practice. And those include, like I said, the decrease of nitrate nitrogen being discharged into that ditch or stream, decreasing the turbidity and volume of the water in those waterways. They require little annual maintenance. They're able to stabilize stream banks and provide wildlife habitat, and also may reduce that peak stream flow. In high flow events, or extremely wet years, there is that bypass system that is utilized. And then also it requires that length of a vegetated buffer area along that ditch or stream. So like I mentioned, you either have to have one of those buffers available or be able to put one in. And it requires soils with a high organic matter and low in sand or gravel, and there must have stable banks as well. So saturated buffers were added in 2021 due to the number of studies submitted, their geographic relevance, and the quality of work. The 40% nitrogen reduction is the median value of the 27 site years selected for the inclusion in the science team's assessment. There is no phosphorus reduction associated with saturated buffers. And then the estimated annual operation and maintenance cost is $10 per acre per year. And that factors in the installation cost, the expected practice life, and then the drainage area that is treated. So here on this slide, there's also a photo of me presenting our saturated buffer model at the Farm Progress Show this year. And in the photo, that water control structure is on the left there, and then that distribution line that would be perforated and running underneath that buffer is there on the right. So another conservation practice that I will be discussing today is water and sediment control basins, or WASCOBs. that are being added to the nutrient loss reduction strategy best practices in the 2023 biennial report. So water and sediment control basins, or WASCOBs, are a structural sediment erosion control practice. So these are earth embankments or combination ridge and channel constructed across the slope of minor drainage ways in agricultural fields. And they can reduce sediment and total phosphorus loads, lessen gully formation, which is shown in that top photo, and reduce and manage runoff. Water and sediment control basins, or WASCOBs, collect and store runoff water, reducing the flow of runoff and delaying flood peaks. So once water is collected, it is slowly released through a tile intake and or through soil infiltration, reducing erosion, preventing gully formation, and removing that sediment from the water. So WASCOBs are constructed across small drainage ways where they intercept runoff, and the basin detains runoff and slowly releases it, allowing the sediment to settle. Generally, WASCOBs use an underground tile outlet to control the release and carry the runoff in a pipe to a receiving stream or ditch. And while terraces are usually really long and follow the slope of the land, WASCOBs tend to be more short, and they're placed in those drainage ways. So WASCOBs typically work better than terraces for land that's more irregular and has those inconsistent slopes. So water and sediment control basins are Conservation Practice Standard 638. And again, ultimately, the purpose is to reduce gully erosion, trap sediment, and reduce and manage runoff. The capacity for water and sediment control basins are an anticipated 10-year sediment accumulation. And for location, they're located in drainage ways and either can be installed singly or in a series. And when installing, you have to adjust the location to fit the topography, maximize storage, and accommodate farm equipment and other farming operations, and also making sure to avoid any impacts to any adjacent properties. So when choosing the location, it is also important to evaluate the extent of the ponding that will occur from the basin, because basins need to be built large enough that they can both collect both water and sediment without overflowing. And then maintenance is also required to keep the basins functioning properly, which just includes periodically removing any collected debris and sediment. So there's also a list of pros and cons to consider for the adoption or implementation of WASCOBs. For pros, those can include those reduced gully erosion and formation, the separation of that sediment from the water, and then those reduced total phosphorus loads. They're able to make hilly land more farmable by controlling the water flow. And when they're designed on the upstream side, so that land can still be used for farming. Some cons can include that initial cost of installation, the equipment and labor needed to clean out the basins of sediment and debris, maintaining the outlet, and maintaining the grass backslope. And then if not maintained or designed properly, uncontrolled overflow can lead to increased erosion and or issues with runoff. So where exactly should WASCOBs be used? This practice applies to sites where the topography is generally irregular, gully erosion is a problem, runoff and sediment damages land and works of improvement, stable outlets are available, and then WASCOBs alone may not be sufficient to control sheet and rill erosion on sloping upland areas. So additional practices may be needed to adequately protect sloping upland areas from erosion and protect downslope water quality. So WASCOBs were a practice that were added in 2023 due to the inclusion of additional Illinois-based research. And this is a sediment control practice, and evidence is currently lacking for a nitrate nitrogen loss reduction efficiency value. So currently there is no nitrate reduction associated with WASCOBs, but there is a 60% phosphorus reduction, which is a mean value found in literature review. An estimated annual operation and maintenance cost is $64 per acre per year, and that factors in the installation cost, the expected practice life, and the drainage area that is treated. So now I'm going to hand things back over to Rachel to wrap things up.
Thank you, Nicole. So we just wanted to also provide you places where you can find more information on these practices, as well as other ag conservation practices that are supported by the nutrient loss reduction strategy. And so we discussed these and other practices on our Illinois Nutrient Loss Reduction Strategy podcast, which is co-produced by Nicole, Todd Gleason, and myself. And we also have a supplemental blog that goes along with the podcast. And our podcast episodes typically include professionals that are doing the research on the particular conservation practice, as well as including a farmer that's interviewed that has implemented the practice, and they provide their experience with the installation of the practice, the use of the practice, as well as provide information for other farmers that might be interested in implementing that practice. So I think you can use the QR codes on this screen, or we'll be putting the links for the podcast and the blog in the chat as well. So please feel free to check that out. And you can find additional resources at the Soil and Water Conservation Society's media library. We're putting the link for that, as well as ISAP, or the Illinois Sustainable Ag Partnership, in the chat as well. Now, ISAP has a large number of partner organizations, which include Illinois Extension, the Nature Conservancy, American Farmland Trust, Illinois Corn, Illinois Soy. There's a large number of partners that are working together on this effort. And they have additional resources on their website and trainings that you can go through, including the conservation training program. And they have other resources, including an EduField incentive directory, which was just put out earlier this summer, and a cover crop incentive directory as well. And you can use that to find different cost share programs that can be used in combination to help offset the cost of cover crops, the purchase and adoption. And with that, we would like to encourage you all to come to the October Everyday Environment webinar, which is Monstrous Mussels, Creepy Carp, Explore Aquatic Invasive Species of Lake Michigan. And I believe the registration link is also going to be in the chat for that as well. And with that, we'd like to say thank you for spending part of your afternoon with us. And please go and fill out the survey. The link will be in the chat, as well as in the follow-up email, or you can use the QR code on the screen. And reach out to either one of us if you have any questions regarding the nutrient loss reduction strategy or some of the different ag conservation practices. We're happy to meet with you and speak with you. Or if there's anything that we can do to help support the work that you are already doing, please reach out. And with that, we will open it up for questions.
When you were talking about terraces, somebody was asking what type of vegetation do you plant on terraces?
I think it depends on your goals. So if you can plant grasses, but if you would like to attract pollinators, then you can use a pollinator mix instead. But anything that's a permanent type of cover.
Awesome. And oh, go ahead. No, okay. And Robert was asking, are terraces different from traditional waterways?
Yes. So traditional waterways are more like a ditch that have grass cover on them, where terraces are an embankment that has an outlet associated with it, and it's used more for hillier topography rather than on, I guess in my mind, grass waterways are typically more on level ground or slightly rolling, whereas terraces are used on slightly steeper topography.
Those are all the questions I have in the chat. If anyone else has any more, please feel to either unmute yourself or type it in the chat and we'll answer it.
Oh, and to add on to the vegetation type, I was reminded that it's usually cool season grasses that are adapted to the site, and it's based on the soil drainage. The seeding table describes the species and seeding rate of the conservation practice, which is 342, and I will put that in the chat real quick.
Wonderful, wonderful. Well, thank you so much to you two for just giving us all the down low on the nutrient loss reduction strategy and those new practices. Really exciting. I'm excited to see, what that report comes out in the next year, right? We just released the last one, so it should be 2 years, right?
No, it'll be, don't quote me on this, but, and Joan, please don't kill me. We're tentatively releasing it at the beginning of December.
Oh, okay. Well, I'll look forward to that email asking about our practices too. So wonderful. And everyone else, definitely head out and see what's next month. I'm excited to see that the aquatic invasives in Lake Michigan and what kind of monstrous mussels and creepy carp are coming our way. So thank you everyone for your afternoon and have a great rest of your day. And we'll see you next month.
Thank you, everyone.
Yep, thanks everyone.